Welcome to NASA's Jet Propulsion Laboratory in Southern California. Days ago, NASA's most sophisticated and capable rover to date landed on Mars, the Perseverance Rover. Today, we'll see Mars like never before with new photos and videos. Our panel today will help us understand how Perseverance captured what it's like to land on Mars and what the landing site looks like. I'm your host, Raquel Villanueva, and joining us is Matt Wallace, Perseverance Deputy Project Manager, Dave Gruhl, Perseverance Entry, Descent, and Landing Camera Suite Lead, Al Chen, Perseverance Entry, Descent, and Landing Lead, Justin Mackey, Perseverance Imaging Scientist and Instrument Operations Team Chief, Jessica Samuels, Perseverance Surface Mission Manager, Ken Williford, Perseverance Deputy Project Scientist, and to tell us what this all means for NASA and exploration, Thomas Zurbuchen, Associate Administrator for NASA's Science Mission Directorate. We will take questions during this briefing. If you're a member of the media on the phone lines, press *1 to be put in the queue. If you're on social media, use the hashtag #CountdownToMars. Now, to get us started is JPL Director Mike Watkins. Now, I will step aside for him to give his opening remarks.
Thank you. Welcome back to JPL. We have a jam-packed press conference today, and I was just looking at the team here. I think we're trying to add it up, maybe 100 years of combined experience with Mars rovers on the panel today. Now, we have been working very hard since we landed. The surface team has been getting the rover set up for the surface mission. They've been working Mars time over the weekend, making fantastic progress, and you'll hear about that today. You'll also see some brand new images and videos that we acquired over the weekend, or downlinked over the weekend. And these are really fantastic images of the surface of Mars and the rest of the descent imagery that we got a preview of on Friday. These images have always been part of the history of JPL. We have taken everyone along with us on our journeys across the solar system, through the rings of Saturn, looking back at the pale blue dot, and incredible panoramas on the surface of Mars. This is the first time we've been able to actually capture an event like the landing of a spacecraft on Mars. And these are pretty cool videos. And we will learn something by looking at the performance of the vehicle in these videos. But a lot of it is also to bring you along on our journey, our touchdown to Mars, and of course, our surface mission as well. And these are really amazing videos. We all binge watched them over the weekend, if you can call a 1-minute video binge watching. But we watched it many, many times, and it's really fantastic. And just to show you how far we've come in the history of JPL, I want to show one image. This is from Mariner 4 in 1965. So this was actually the first data, first images sent back from Mars by Mariner 4, and that was hand-colored by the engineers according to a code, kind of like a paint-by-numbers painting. And there it is, the first color image, hand-painted. And so when you see these videos later, I think Dave Gruhl and Justin Mackey will be overjoyed that they didn't have to hand-color each one of these images. So my hat is off. It's a great press conference today. My hat is off to the team, for getting the rover to where we are and these fantastic images down. And to learn more about that team, let me introduce Matt Wallace.
Thanks very much, Mike, and thanks for the nice words about the team. I'll try to be brief because I want to get to this video, and I know you do too. I just want to give you a little bit of background on how this whole thing started. My daughter is a gymnast. She's been a gymnast since she was a little kid. And when she was about, 11 years old, and the project was still in formulation, she asked me for one of those little sports cameras. And being the indulgent parent I am, I got her the sports camera, and she put it in the harness that it came with, and she put the harness on, and she did a backflip. And I don't know about you, but I cannot do a backflip. But when she showed me the video, and I watched that camera pan up to the ceiling, and then the room go upside down and then somehow right itself as she landed on her feet. I felt for a moment that I had a glimpse into what it would be like if I could do a backflip. And that was the moment that inspired a phone call to my friend Dave Gruhl over here. And that's what led to this system, this entry, descent, and landing camera system. We call them the EDL cams that you're about to see the product of here just in a moment. Now, I don't know about you, but it is unlikely at this point in my career that I will pilot a spacecraft down to the surface of Mars. But when you see this imagery, I think you will feel like you are getting a glimpse into what it would be like to land successfully in Jezero crater with Perseverance. And so without any further delay, I'm going to turn it over to Dave, who'll describe the system, and we'll get to the video. Thanks.
Great. Thanks, Matt. The idea of adding a ruggedized commercial off-the-shelf hardware onto a flagship spacecraft to do a nice-to-have function proved to be quite an interesting challenge that Matt handed over to us. Along the way, we encountered one, maybe two people who were a little bit skeptical of what we were trying to do. But thankfully, we had the full support of project leadership, all the individuals directly supporting the 2020 mission were super excited to help, and in the end, we were able to actually make it happen. Our EDL CAM team were guided by two requirements, if you will. The first one was that the entry, descent, and landing system, camera system, must do no harm to the flight vehicle. And that's especially important during EDL. This was our one critical requirement, and as you all saw last Thursday, that requirement was met. The second item is not so much of a requirement as it is a mantra, if you will. We get what we get, and we don't get upset. We wanted our EDL cam system to get onto the vehicle and return amazing imagery of the vehicle landing in Jezero crater on Mars. Like every other element on the Mars 2020 spacecraft, individuals worked really hard and went above and beyond to make sure that their piece of the spacecraft did what it was supposed to do and would be successful. But in the end, we knew that our entry, descent, and landing camera system, the mission could still be 100% successful if our camera system didn't work. And if we could even get just one image or one piece of information back during EDL, that we shouldn't get upset and we should be excited. So as you probably realize after last Friday's press conference, the EDL cam system successfully captured some amazing imagery of the vehicle's descent and landing on the surface of Mars. We collected a little over 30 gigabytes of information and over 23,000 images of the vehicle descending down to the surface of Mars. As a quick introduction, if I could have the first graphic, a reminder for some of you exactly what are the sensors that we included in the entry, descent, and landing camera system. There are 3 cameras that are located on the top of the vehicle on the back shell. Those cameras actually capture high rate, 75 frames a second imagery of the parachute inflating in the Martian atmosphere. Now, one of the cameras stopped operating coincident with the mortar fire when the parachute was deployed, and that's to be expected. It is a very high dynamic environment, but luckily the other 2 cameras continued to operate as expected and captured some amazing footage of the parachutes inflating in that Martian atmosphere. We put one camera on the bottom of the descent stage. That camera looked down on the rover as we lowered the rover on the bridles. The mobility system latched into position, and then the vehicle touched down onto the surface of Mars. We also installed 2 cameras onto the rover, one on the top of the vehicle looking up on the descent stage so the rover could actually see the descent stage, lower it down to the surface, and then ideally fly off into the distance after it had delivered Perseverance safely onto the surface. And then we also put a camera on the bottom of the rover, which actually looked down on the surface of Mars once the heat shield was dropped away, and that camera continued to capture imagery until the vehicle touched down on the surface of Mars. And then we also put a microphone on the port side of the rover. Now, unfortunately, I do have to say that we did not collect any audio during EDL, but please stay tuned a little bit later in this press conference because we do have some exciting information about the EDL cam microphone. So now the reaction to the EDL cam videos has been absolutely amazing around JPL. And we are super excited to actually share with all of you video imagery of Perseverance landing on the surface of Mars. Please roll the video.
Starting the straighten up and fly right maneuver, where the spacecraft will jettison the entry balance masses in preparation for parachute deploy and to roll over to give the radar a better look at the ground.
Indicate chute deploy.
The navigation has confirmed that the parachute has deployed, and we are seeing significant deceleration in the velocity. Our current velocity is 440 meters per second at an altitude of about 12 kilometers from the surface of Mars.
Heat shield set.
Perseverance is now slowed to subsonic speeds, and the heat shield has been separated. This allows both the radar and the cameras to get their first look at the surface. Current velocity is 145 meters per second at an altitude of about 9.5 kilometers above the surface.
Nav filter converge. Velocity solution 3.3 meters per second. Altitude 7.4 kilometers.
Now has radar lock on the ground. Current velocity is about 100 meters per second, 6.6 kilometers above the surface of Mars. Perseverance is continuing to descend on the parachute. We are coming up on the initialization of terrain relative navigation and subsequently the priming of the landing engines. Our current velocity is about 90 meters per second at an altitude of 4.2 kilometers.
OVS valid.
We have confirmation that the lander vision system has produced a valid solution and part of terrain relative navigation.
Priming. TBA is nominal.
We have priming of the landing engines.
Back shell set.
Current velocity is 83 meters per second at about 2.6 kilometers from the surface of Mars. We have confirmation that the back shell has separated. We are currently performing the divert maneuver. Current velocity is about 75 meters per second at an altitude of about a kilometer off the surface of Mars.
Here in safety Bravo.
We have completed our terrain relative navigation. Current speed is about 30 meters per second, altitude of about 300 meters off the surface of Mars. We have started our constant velocity accordion, which means we are conducting the sky crane, about to conduct the sky crane maneuver. Sky crane maneuver has started, about 20 meters off the surface.
We're getting signals from MRO. Tango Delta.
Touchdown confirmed. Perseverance safely on the surface of Mars, ready to begin seeking the signs of past life.
It gives me goosebumps every time I see it. Just amazing. I hope everybody kept their hands and arms inside the vehicle at all times while it was in motion. So I do need to say, I wouldn't be sitting at this podium and you wouldn't have all seen that amazing imagery without a lot of support from an amazing team, both those who worked directly on the EDO CAM task as well as those who supported us across the project. I thank you for everything you've done to get us here today. Just an amazing, amazing accomplishment. So I'm going to turn it over to Al. Al is going to be our color analyst. Doesn't have a telestrator, but he's going to actually walk through some of those videos in even more detail and actually show you some just incredible things that you can actually see once you look at those videos over and over.
I'm not sure the color commentator is supposed to have as many chills as I do right now and every time I see these videos. But I wanted to add my thanks to the EL camera team. I mean, these videos and these images are the stuff of our dreams. It's been what we've been dreaming about for years. So thank you so much. Let's see. As Dave mentioned, we'll try to walk through what we see a little bit. We won't take that much time because we could spend literally all day looking at these videos, and some of us have spent all the weekend looking at these videos. But we'll just try to show you some highlights of what we've been seeing and invite you all to continue to look for more things as we kind of see new things every time we look at these videos. So let's start with the parachute uplift camera, and let me give you a quick warning to not blink because things go really fast here. You can see that you can get a sense really of how violent that parachute deploy and inflation are. The parachute pack, the parachute is packed so densely that the pack is basically the same density as oak, and it's about 150 pounds. It gets launched out of the spacecraft with a mortar, which is basically a cannon, with a muzzle velocity of around 100 miles an hour. And the spacecraft itself was going about 1,000 miles an hour at this point, going about 1.75 times the speed of sound. So just in case you blinked, let's show you that one more time. You can kind of see that in high speed and then, or real time, and then we'll slow it down and take a look at the details. Okay, so let's try to walk through this a bit slower, this time at about quarter speed, and we'll pause at times to point out things we see. So let's start that rolling. Okay, here you can see the pack getting pushed out of there. You can kind of see the pack right in the middle as it's being pushed, and the parachute lid, which is right on top of it, it's kind of that circle to the left of the pack, was on top of the pack. It was there to protect the parachute during entry. It's got some thermal protection system material on it to keep the parachute nice and cool and protected. And the pack is used to push that lid right off the vehicle, given that cannon force. You can also see some of the other things that have popped off of that lid, which is kind of expected given how violent this launch really is. So let's move on from here. So we keep going out here. You can see the pack reach what we call line stretch. So that's as far as it's going to go. It's where the parachute's going to start inflating. That's about 150 feet behind the spacecraft, and it got there in just under 1 second. So this pack is really moving. That's pretty much, as the parachute starts to come out, you can see the pack is rotated about 90 degrees. That's pretty common. We've seen that in some of our testing here on Earth at high altitude as well. So let's keep going and take a look at the inflation. So that inflation really looks textbook. It's nice and symmetric. The parachute opens in only about 7/10 of a second, again, really fast. There's no evidence of tangling of the lines, which is great. There's about 2 miles of lines in the parachute system, so the fact that we don't see any evidence of tangling or any kind of other misbehavior is great news. And I'm sure we'll be studying this video for many, many years and picking it apart frame by frame. And of course, we have a second camera on board as well that recorded this launch and inflation of the parachute. You might notice the pattern that's on the parachute here. Distinct patterns are useful in helping us determine the clocking or orientation of the parachute. Also, the contrasting sections can be useful in tracking different positions of the parachute, different portions of the parachute as it inflates. So it's especially useful when we have multiple cameras, as we do here, and are trying to track features in the parachute inflating. In addition to enabling incredible science, we hope our efforts and our engineering can inspire others. Sometimes we leave messages in our work for others to find for that purpose. So we invite you all to give it a shot and show your work. Let's move on to the rover download camera and take a look at that in a little bit more detail. So if we start that up, you can see the heat shield falling away very nicely and symmetrically. Pausing here, we can take a look at what we see on the heat shield. First, we see the medley components on the heat shield. You can see the electronics box and the gold wires that lead to all the various sensors that measure the aerodynamics and heating during the entry portion of flight. We can also see some white flecks in different places, both on the heat shield and free flying, which are likely frost that accumulated on the heat shield. That heat shield is really, really cold during cruise, so it's not at all unexpected to see some of that frost appearing on the heat shield on the inside. You can also see something we didn't expect to see if you kind of look at the 4 o'clock position on the heat shield or so, towards the middle, somewhere between the middle and the edge. One of the springs that helped push the heat shield off seems to have come loose. It doesn't, it's not much of a big deal, but it's definitely not what we expected. If you look at the other 8 springs, they actually are where they're supposed to be, all around the edge of the heat shield. There's no danger to the spacecraft here, but it's something we didn't expect and something we wouldn't have seen if we didn't have the camera system to show us what was going on. So let's keep rolling here. We can see that the heat shield basically stays in the same orientation as it flies away from us. It'll come back into view in a little bit. But this is great. This is kind of what we expected in terms of the aerodynamics of that heat shield. It doesn't tumble or do something weird that was unexpected in flight. So that's very useful to have this video to show us that. So in the interest of time, let's skip ahead to about 15 seconds before backshell separation. So starting this video here, you can see that the spacecraft is rocking back and forth while hanging under the parachute. This rocking is less than it was earlier in flight, but pretty much what we expect. There, that white flash was backshell separation, and you can see us throttle up and begin our divert maneuver. You can see the vehicle's turned over, so we're actually beginning to fly east. And that's why you can see the delta over there. As it maneuvers eastward to the eventual landing site, it actually passes over, the field of view will pass over the landing site and then kind of overshoot it a little bit because it's got to stop that horizontal divert that we did. You can see everything's nice and smooth now that the engines are under control, that on-chute parachute rocking is gone. So here we are, slowing down and stopping, and we're coming straight down on our eventual landing site here. You can see that as we really begin to slow down here, you can see the engines as we get lower throttle up there and stop us here. And you can see it beginning to push all that dust around on the ground on the two sides. That shaking there is the rover deploying and the mobility during sky crane. And here we are coming down, and that rocking motion of the rover we'll see in other videos. But that settles down right before we hit the ground in a nice, safe, flat spot. There doesn't appear to be too much of concern that's right below us. So that was the rover's view looking down. Let's take a look at the descent stage view looking down as well during that sky crane portion of flight. So here we go. The rover begins to drop away from the descent stage, and that's the first part of mobility deployed. You can kind of see here right before we pause that the mobility kind of shook a little bit in that first deployment. Here you can see the bridles that are hanging down from the top of the picture. Those are what's supporting the weight of the rover below the descent stage. And if you look down toward the left, the bottom part of the image and toward the left, you can see that gold umbilical. That's what's transferring all the information between the rover and the descent stage, including this video. This picture is coming down from the camera up on the descent stage down to the rover through that cord, in addition to other information that's going back and forth. So as we keep going here, you can see the bogie deploy. That's on both sides of the mobility back. You see those wheels, the back two wheels on either side swing down. That caused a little bit of rocking of the rover as expected, but you can kind of see that kind of settles out a little bit right as we enter that plume and dust cloud as we get down and touch down. And the video ends at touchdown, of course, because the camera that's taking this video is about to leave this area in a hurry on that descent stage after we cut it loose from the rover. So now let's take a look at the rover uplook camera. So now staring up at the descent stage from the rover. So here we go. We got a really close-up look at the descent stage, and we can start rolling that. You can see the descent stage as the rover begins to fall away from it, and see the effect of that rover wobble from the mobility deploy. So pausing here, the first thing that most people will probably notice is that there's no plumes or no visible smoke or anything else coming out of the rockets at the corner of the descent stage. That's expected. Hydrazine isn't a combustion reaction when we burn it. The exhaust products are nitrogen and hydrogen, which are clear. So we expect the plumes to be clear. That's what we see in tests here on Earth as well. So I can promise you those engines are on, though. One thing you can see in the Earth testing we do is that the thrust chambers of those engines get kind of hot and glow pink. And you can kind of see that in the engines here, especially if you look at the engine at the very top right of this image. If you look closely right above the engine bell there on the thrust chamber, you can see little streaks of pink on there. And that's what's happening. As the engines have been on for a long time, they get really hot. And that heat shows up there in those pink stripes that we see. So take a look at that closely when you get a chance to look at the image in some detail. As with the previous videos, you can see the bridles that are supporting the weight of the rover there at the bottom now of this image, and that umbilical, again, transferring data back and forth between the descent stage and the rover. So let's keep going a little bit more. You'll see the image begin to wobble a little bit here. I can promise you it's not the descent stage wobbling, it's actually that rover tipping back and forth a little bit as we saw as the mobility deploys, both the first initial mobility deploy and then the bogies deploying. As we near touchdown, let's slow it down a bit and proceed in slow-mo here. So now we're watching about quarter speed. Things are getting pretty dusty here as we get down toward the bottom. Take a look here at the bottom left of this picture. You'll see actually the instant that we cut the descent stage away. And you'll see those throttles begin to get retracted up toward that descent stage as they're pulled up. And this is as planned. There they go. See as they got yanked up there right before. And then we'll see the descent stage begin to turn and ascend and head out toward the northwest with the umbilical dangling behind it. Since the rover was pointed almost directly to southeast, the descent stage chose to go toward the back. That's also to make sure, of course, that the engines don't plume the rover, that we don't damage the rover with that engine thrust. So we sent that descent stage off to the northwest, which Jessica will show you about in a little bit. So I can and have watched those videos for hours and keep seeing new stuff every time. So I invite you all to do that too. So now I'll turn it over to Justin, who will talk to you a little bit about the images we've been taking on the ground.
All right, thank you, Al. I'm Justin Mackey. I'm the Mars 2020 Perseverance imaging scientist here, and I develop imaging systems at JPL. And when Dave asked me to help out with the EDL cam development about 6 years ago, I was really excited about it. I knew it would be challenging and interesting, and even possibly spectacular, but I had no idea that it would be this amazing, and we are so happy and proud, and I just want to thank Dave and Matt for just giving us the leadership and giving us the chance to do this. Like Matt and Dave and Jennifer and Rick and others on the project, I've actually worked on all 5 of the NASA rover missions, and as part of my job, I review images from Mars like every day. That's what I do. And when I saw these images come down, I have to say I was truly amazed. And I know it's been a tough year for everybody, and we're hoping that maybe these images will, help brighten people's day. Your smartphones and make them your screen backgrounds and things. I'm just really happy that it all worked out. So now we're on Mars, and I'm going to talk a little bit about what we've been doing over the weekend. Over the weekend, we deployed the RSM, and if you go to the first picture, there's a picture of the remote sensing mast, the RSM, which is that mast on the rover, and you can see the navigation cameras up there, the left and right navigation cameras, or nav cams as we call them. This is another new imaging system that we've developed here specifically for the 2020 mission. These cameras represent a pretty significant advancement over previous imaging systems that we've flown. These are 20 megapixel color cameras with very high resolution and wide angle lenses that we use to basically map out the surface as the rover drives, and then we use these images to do planning and things. And so the first thing we did after we deployed the mast is we started imaging the surface. So the next slide shows one of our first images from the cameras. This image is actually in low resolution mode. So it's 1/4 of the full resolution of the camera, so it's been shrunk down. But you can see right there the vista that we're seeing. This is the rover, obviously, on Mars, and you can see some of the material that landed on the deck. But everything looks in good shape, and so we're using these images to inspect not only the vehicle, but the surface around us. The next slide shows the view down towards the surface. You can see the wheels there. This is the same surface you just saw in the EDL cam videos. You can see some of the scouring that the rocket plumes did for us, clean it off, make it nice and clean so we can take pictures of it and dust it off for us. The next slide shows a view looking out towards the south, and this just an amazing scene here. This is it. This is Mars. We're here in our place that we're going to be exploring over the next months and coming years. And it's just really exciting to see, these scenes look familiar to us. They look Earth-like in a sense. You see the mountains back there and the rocks and things. It's just, it really is the surface of an alien world, and we just arrived. You can also see some more scouring there over on the right. The next image looks over towards the west. You can see the delta out there on the horizon, and again, more scouring from the rocket plumes. And then we take all of these images and we stitch them together into panoramas. And so that the next frame shows the full panorama from the nav cam stitched together. We're still working out the calibration and things, so this is approximate color, but it just gives you a feel for the vista here that our new environment that we're going to explore, and we're hoping everyone will join us in seeing these images. Today we're going to be releasing a whole slew of raw images. It's been a fire hose of data, basically. We have thousands of images already from the EDL cameras, nav cams. You've seen the HAZ cams. And so we will be putting those out on the website today for people to download and process yourself, or just look at the great pictures, find your favorite picture, and make it your screen background. And then the last image that I just wanted to point out is the first image, one of the first images from the Mastcam Z camera. This is another next generation imaging system on the rover. Jim Bell is the PI. I'm the deputy PI for this, working with our industry partners, MS Cubed, down in San Diego. This is just a fantastic imaging system. This is a preview of things to come. This system has a zoom lens on it. That's what the Z stands for. And we are going to get incredibly high resolution photos from this imaging system. I just wanted to point out a few things in this picture. On the far right, you can see those cables where they had been cut in the video that you just saw. So there's kind of a close-up of that. And then just in the middle, to the left of that black instrument, that's the rover upload camera. That's the camera that actually took the video of the sky crane as we were coming down. And then in the bottom of the frame is the Mastcam Z calibration target set. There's two of them. There's the circular one with the shadow post, and then the color chips on the bottom. There's another cal target in the back. That's the SuperCam instrument with our partners from Los Alamos and in France. We're going to be commissioning SuperCam over the next few days. And then finally, just as a teaser, I'll point out that there is a little antenna there to the right on that box, the center right. That is the helicopter antenna. It's a helicopter base station location. And preview of things to come. We're excited about that as well. So with that, I'm going to turn it over to Jessica to talk about latest status.
All right, thank you, Justin. I know you can attest firsthand to being in the control room and the excitement that everybody has been experiencing, seeing all these images from the surface. And as they come down, we're immediately sharing them and everybody clapping and smiles all around. So, great camera suite. So I am happy to report that Perseverance is healthy and continuing with activities as we have been planning them over the first few sols on the surface. To date, which is really only just 3 sols of activities and one more, and coming up later this afternoon, we've executed 5,000 commands. So lots of instructions to the vehicle for her to perform, and having everything come back exactly how we've been wanting it to with respect to our health checkouts and our instrument checkouts. So things have been going well. A couple key highlights. So we have fired and released our launch lock restraints to allow mechanisms to be deployed. We saw the remote sensing mast, but one of those also being the high gain antenna. Now, this is important for the high gain antenna to be deployed because it increases our uplink rate to the rover, and so it will allow us to send a higher volume of instructions to Perseverance and allow her to perform more involved activities over the days to come. Additionally, with respect to our communication, we have established a strong communication link with all of our relay orbiters and our partners, the Mars Reconnaissance Orbiter, the MAVEN Orbiter, Trace Gas Observer, the TGO, and Odyssey spacecraft. And so we thank those teams and are happy to be able to use those assets to relay all of the information that all these beautiful images that we are looking at today. The remote sensing mast motion checks were nominal and as expected. And all of our instruments have gone through their initial checkouts, and we're happy to report that they are all performing nominally and as expected. Now, when I say nominal, it really means fantastic, because we can't wait to continue to use this payload suite. Our backup computer was turned on yesterday, and that was in preparation for our upcoming flight software transition, which we will be performing over the next few days. And the Ingenuity helicopter has also been checked out, and we have performed a battery charging event, which we will continue to perform over the weeks to come in preparation for that aspect of the mission. But looking ahead, we are excited to be on our surface flight software. It is a much more surface capable, a lot more capabilities for the surface mission as part of this flight software load. It will take us a few days to transition, but once we're on that load, it will allow us to do further in-depth checkouts of the instrument, as well as deploy the robotic arm and exercise some of the turret items that you see in this image. So you can see that we have our coring drill in the center, our Pixel and Sherlock instruments mounted to the side, and that black tank is to support the gas dust removal tool, which will remove dust from the surfaces that we will be inspecting later. So coming up here, the wheels, if you noticed in the image now, are off to the side. We will be performing a wiggle. We'll straighten those up. We'll do a short drive. And as I mentioned, deploy the robotic arm, and then continue with further in-depth checkouts. So we are very excited to be happily on the surface and exercising our system and looking for what's ahead. So going back to our partnership with the larger Mars spacecraft and science teams and community, we're really excited that the MRO spacecraft, Mars Reconnaissance Orbiter, and the HiRISE team was able to find our hardware on the surface of Mars. And so if you see in this image, if the next pop-up, you can see that we have the descent stage, the parachute, and the heat shield all here in this image. With a few stats here, the descent stage is about 700 meters away from where Perseverance is on the surface. Parachute is about 1.2 kilometers, and the heat shield about 1.5 kilometers. And so it's very exciting that we can see all these different components now that we've landed on the surface. And as a special treat, the HiRISE image was able to actually acquire the entry, descent, and landing event from their perspective, and we can never have enough images of this activity, and so this is a fantastic view. But I'm going to send it back to Dave here. He, as part of this suite, we have one more surprise, or one more gift, I'll say, that we've been able to receive from this package. Over to you, Dave.
Thanks, Jessica. So I think we probably have overloaded your visual sense for a little bit. So we're going to do something a little bit different, and I'm going to have some fun here for a second too. So I'm going to get rid of this. And I'm going to talk to you now with this. This is the microphone that was part of the EDO camera system. When the EDO cam system was first envisioned, it was set up as just a bunch of cameras to capture some amazing imagery on the surface of Mars. And about a year or so after it was first conceived, I got a phone call, another call from Matt. After talking to headquarters, asked the question, could we possibly put a microphone as part of our EDO camera system? So we worked with the team, we took a look, and sure enough, it was something that we could do. And so we started off that detailed design and identifying a microphone that would work for us and getting it onto the vehicle. About a year after this first started, I was giving a tour at JPL. And I happened to mention to the group that I was giving the tour to that the decision had come down and we were working to actually include a microphone onto the vehicle. And after the tour was done, a gal came up to me and she said some things to me that I won't forget anytime soon. She said, I'm super excited that you guys are going to try to put a microphone onto the rover and get it to the surface of Mars. And I was very appreciative. And I asked her afterwards, I said, I'm curious, why is it that this relates to you so much? And her response was that her sister was visually impaired. She was not able to see these images that we saw earlier or that we sent down in the past. And while she tries to describe them to her, she felt that she just can't quite capture that same sense of amazement that she gets when she gets them visually. And that by actually getting a microphone onto the surface of Mars, the hope was that she'd be able to experience things on Mars the same way that she was when she actually looked at them. And that stuck with me. We continued to work super hard to make sure that this microphone would work. And that's part of the reason we were disappointed why it didn't work when we actually went and did our entry, descent, and landing sequence. I wish I had actually captured that individual's name. I would love to reach out to her now and say, we've done it. I hope your sister is enjoying it. Because what I'm going to show you in a second, or what you're going to hear in a second, is actually the first sounds being recorded from the surface of Mars. So there are 2 microphones on the Perseverance vehicle. There's this microphone here, which is part of the entry, descent, and landing system, and there's a second microphone that is on the SuperCam instrument. And we're counting on both of these instruments, recording some absolutely amazing sounds from the surface of Mars. So with that, I invite you now to, if you would like to close your eyes, and just imagine yourself sitting on the surface of Mars and listening to the surroundings. If I could have the first one, please. So that gentle whirl that happens in the background, that is a noise made by the rover. But yes, what you did hear 10 seconds in was an actual wind gust on the surface of Mars, picked up by the microphone and sent back to us here on Earth. The analysis indicates that was around a 5 meter per second type of a wind gust. So we can sit here now and actually tell you that we have recorded sounds from the surface of Mars. So we have a second one, which basically further reduces the noise of the rover, so you can just hear what the wind would sound like on Mars. And once again, I invite you to sit back and have a listen to what it would sound like to be on Mars. It's cool. It's really neat, overwhelming, if you will. I can't remember what I was going to go and say next. So we're looking forward to doing some amazing things with the microphones going forward. We need to work with the ops team. There's some great science that they're looking to do. We're hopeful that we continue to use these microphones, both the SuperCam microphone and the EDO cam microphone, to capture sounds, perhaps the rocks interacting with the surface. SuperCam is going to use theirs to get some great data of them zapping rocks. So as you've heard and will continue to hear, we're just beginning to do amazing things on the surface of Mars. And now Ken is going to talk to you a little bit about the science that we've done to date and what they're looking forward to doing as we continue to move forward.
Thanks, Dave. And I'll start by just taking this opportunity to say to Matt, Dave, Al, and everybody else on this fantastic team, thank you for the ride of a lifetime. That is just incredible, what we've seen today, and what I'm sure we'll continue to see as the mission unfolds. So with all the focus on these spectacular videos and audio, we wanted to make sure to remind you that there's plenty of science going on already, with hundreds of team members poring over every new image. So if we can get the first of those images, as you'll see in this NavCam frame, we start with what may seem like very basic observations: light rocks, dark rocks, holy rocks. That's holy with an E. We use these very generic terms at this early stage until we have more data that allow us to test our hypotheses and make more confident interpretations. Follow along with the mission, and you'll see that this is a theme. As we get closer, our view of Mars continues to resolve and a coherent story emerges. Next image, please. Finally, I just want to briefly point out that we are finding real science value in these EDL cam videos. Here you can see a beautiful new perspective on the Jezero Delta. And if we can get the next image, also a new perspective on some of the beautiful stratigraphy around our landing site, which is up near on the far right side of this image. So now, to put all of this in context for us, I'll hand it over to Dr. Thomas Zurbuchen.
Well, what we've seen here today is really nothing short of amazing. You know, and perhaps you've had moments like this before. Some of you have told me that I was too young to remember, but they had a moment like that, for example, when they observed the first landing on the moon. They had moments like that where it felt that we took a big leap, not just in this case because of at JPL or at NASA, but a big leap as humanity. Of course, it's a leap that was enabled by work over decades, and on this mission for close to a decade. So what's possible today, or what feels possible, is different even than yesterday. It's how it feels to make history, and that's how I feel today. I'm so moved by this. Wow. The video of Perseverance descent and landing, and the amazing panorama, and the first wide landscape shot of Jezero Crater seen with human eyes, and the first Martian sounds are the closest you can get to landing on Mars without putting on a pressure suit. That video, I believe, should become mandatory viewing for young people who not only want to explore other worlds and build spacecraft to take them there, but also want to be part of diverse teams achieving all the audacious goals of our future. At the center of that is a team, and I'll ask for the next image. You should know, I met this team. I see me there in a dark suit next to Dr. Laurie Glaze, the Planetary Division Director, and Al, he just talked to you, is on his knee in there, and that's the entry, descent, and landing team. And we met him just hours before that historic landing. And I love this picture because, of course, the event today demonstrates that the human aspect of exploration. And that is, of course, every reason for what we can do at NASA, and also why we do things. The video and audio images here provided to us are from the surface of Mars, and sometimes we forget if we look at that. Well, Robert shouldn't get all the fun. We want to make sure that all of us on Earth see and feel what it's like to be on Mars and explore other worlds. I'm so excited for the more than 1 million students who joined the Mars Student Challenge, and the many more across the world who will be inspired by these images released today and even yesterday. Their journey is also just the beginning. Just imagine Perseverance sitting on a hill, recording the next Martian landing with a cargo that is basically a rocket, and then the first from another world with samples bound for Earth that are collected by Perseverance now in the near future. Imagine follow the entry, descent, and landing of the first human crew on the planetary surface sometimes in the future. These future historic events, which I'm confident will happen, will be enabled by women and men working in diverse teams. Imagine the goals we can achieve together. So what is possible? Sometimes to address that question, it's good to look back and think where we've come from, just like my friend Mike did earlier. We've been on a journey, both as a human race for quite a while now, and I don't want to show this next image of Sojourner, of the Pathfinder mission, which was designed for 7 sols or Martian days or so, maybe 30, ultimately lasted for 85 Earth days in 1997. I remember that really distinctly. A true Pathfinder indeed, that weighed 23 pounds, and returned a surprising amount of data back to Earth, and a surprising amount of science for many scientists, I must say. Some people didn't expect quite that much, and that's what happens sometimes too when you innovate, just like we've seen here. We've grown from that seed. Now Perseverance is the size of a small car, and it's ready for us for the next shine leaps. And here's a picture that we're putting up that is one of the many pictures that we're releasing. And of course, it's a picture, one of my absolute favorites, and that's a picture of the sample caching system on there, because it's that sample caching system that will connect this mission to the samples that will bring back to Earth and other historic feed we're working on. This system is on the surface of Mars now. I remember distinctly looking at it before we packed it up from JPL and moved it over. Then, of course, launched it from the top of a rocket. This, my friends, is one of the indelible moments in NASA's history where what we can see and what we can learn and what we can hope for in the future, and the extraordinary emotions that makes it feel all of us coming together. That human element will fuel our future at Mars, which is bright indeed. And it will fuel the dreams of a new generation that will return to Mars and also study the samples that we will eventually bring home. I'm so grateful to this team and literally the thousands, both at JPL and within the US and around the world, to all of you who have engaged in this mission. As has been noted, the raw image pipeline is opening up. Please go take a look at these data and play with them, especially those of you, the children and the youth that have signed up to our educational campaign. What can you find in these pictures? And who's going to compose the first piece of music with actual Mars sound? Mike, Matt, Jennifer, Al, many of you leaders, I could not be more proud of both you and your team. On behalf of our entire NASA leadership team, a heartfelt and a proud thanks to you. For the record, Matt, I'm so glad for your idea about these cameras. We will learn a lot from that, much more than we ever expected. And of course, this is just a start. For the surface team, the real work starts now to evaluate the surrounding and start a plan and our trajectory across Jezero Crater. It's a big team and there are lots of discussions, but that's science in action. Stay with us. There is much more amazement to come. Back to you, Raquel.
Thank you, Thomas.